Children, can you find the roots of a quadratic equation in seconds? Or can you create a polynomial if you are given with its zeros? Yes, today we are going to complete the entire chapter polynomial in one shot. The first thing is identifying what is a polynomial. The quick tip is the powers of x, or whatever is the variable in the polynomial, should not be a negative number, should not be a fraction. For example, if you look at 3x plus 5, the power of x is 1. Yes, this is a polynomial. Since the power of x is 1, this is a linear polynomial. In the second case, the power of x is 2. It's a quadratic polynomial. Similarly, 2x cubed, it's a cubic polynomial. While if you look at root x, the power of x is 1 by 2. The fractional powers are not allowed. If you look at the polynomial 1 by x, this means the power of x is minus 1. Again, the negative powers are not allowed. Similarly, x to the power minus 2, negative powers are not allowed. So these will be not the polynomials. So the first thing is, in order to identify a polynomial, we should have the variables having non-negative integer powers. So not making it any complicated, just in a very simple form, this is how your polynomial identification is needed. Then it comes to the degree. The degree of the polynomial will be the highest power of the variable. For example, x square plus 2. Degree of the polynomial is 2. X cubed plus 3x square minus 7x plus 4. Degree of the polynomial is 3. So degree is nothing but the highest power of the variable in the given polynomial. If the degree is 1, the polynomial is linear. If the degree is 2, the polynomial is quadratic. If the degree is 3, the polynomial is cubic. If the degree is 4, the polynomial is quartic or biquadratic. Let us run through the quick examples. 2x plus 3, 2x, 3y. All this will be your linear polynomials. Similarly, for quadratic, x square minus 7, 3x square minus 2x plus 3. All this will be your quadratic polynomials because the power of x is 2. Cubic polynomial, degree 3, x cubed plus x minus 2, 7x cubed. Similarly, for a quartic polynomial, x to the power 4 or any polynomial which has the maximum power of x is 4 will work for a biquadratic or quartic polynomial. What is the zero of a polynomial? This is the very important concept, children. A zero of a polynomial is that value of x. When you put it into the polynomial, you get the answer as 0. For example, if my polynomial px is given as x minus 2, so I'll equate it to 0, x is equal to 2. So that means if I substitute x as 2 here in this polynomial, I'll get a 0. And such values of x are nothing but known as the zeros of a polynomial. So for a linear polynomial, you will have at most 1 0 because the power of x is 1. So at most you will have 1 0 for a linear polynomial. So now let us have a look at quadratic polynomial. A quadratic polynomial can have either 2 zeros or it can have 1 0 because both the values of x will be same. So or you can say 2 equal zeros, or it can have no real zero. So the graph of the quadratic polynomial is actually a parabola. The parabola can open upwards, the parabola can open downwards in whatever way. So if the parabola cuts the x-axis at two different points, in that case, you will have two unique zeros. If the parabola just touches and goes the x-axis, in that case, you will have same two values of x. We say that it has 1, 0. And if the parabola is not touching the x-axis anywhere, it's just above the x-axis or below, but in whatever case the parabola is not touching the x-axis, in that case, no real zeros are possible. That means in that case, you have the imaginary roots, which is out of the scope for us at the moment. So we will just write that no real zeros in that case. The maximum possible zeros is the degree. So if it's a quadratic polynomial, the maximum possible zeros are 2. You cannot have more than two zeros for a quadratic polynomial. Next, the most important thing is the relationship between zeros and coefficients. Let's say a quadratic polynomial is represented as px is equal to ax square plus bx plus c, then we say that its zeros are alpha and beta. So instead of saying two values of x, we just say that, let's say one zero is alpha, another zero is beta. So then the sum of this alpha plus beta can also be derived directly from the polynomial by looking at these coefficients b and a. So we can say that sum of zeros alpha plus beta is minus b by a, and the product of zeros, which is alpha and into beta, and the product of zeros, which is alpha into beta, is given by the value of c by a. For example, I have a polynomial x square minus 5x plus c. So in this case, a will be 1 if you compare it with ax square plus bx plus c. So in this case, a will be 1, b will be minus 5, c will be 6. So sum can be written as alpha plus beta, which is minus b by a. So minus b itself is negative. So this will be 5. And the product will be c by a, which is 6 by 1 or 6. If we have to calculate the roots of this parabola, what we can do is we can use alpha plus beta and alpha beta to find the roots, or else we can solve the polynomial by middle term splitting here. X square minus 3x minus 2x plus x. So this means x into x minus 3 minus 2 into x minus 3. So this means x minus 2 into x minus 3. So I've got two values. Alpha is 2 and beta is 3. And you can verify the relationship. Sum is actually alpha plus beta, which is 5. Product is 6, which is alpha into beta. The next concept is if we are given with alpha and beta. So let's say we are given with the zeros as alpha and beta. As let's say 2 and 5, and now we have to form the polynomial. We have to form the polynomial. So what's the standard form? It's always x square minus sum of roots into x plus product. X square minus sum of roots into x plus product of roots. So if we are able to assemble all that, we'll be able to identify our polynomial. So in this case, alpha is 2, beta is 7. So alpha plus beta will become 7. And product is alpha into beta, which is 2 into 5, 10. So px will be equal to x square minus 7x plus 10. So we began with identifying the polynomials, then we understood what are the zeros of the polynomials. We looked at how the zeros contribute to the parabolic graph. Then we looked at how to find the zeros, the relationship between zeros and coefficient. So there are 3 identities which are needed in polynomials. Sometimes they ask you to find alpha square plus beta square or alpha cube plus beta cube. So remember, if you have to find alpha square plus beta square, don't go about finding alpha and beta separately. You can use sum and product directly. I can write alpha square plus beta square as alpha plus beta whole square minus 2 alpha beta. So this becomes alpha square plus 2 alpha beta. And then this minus 2 alpha beta cancels the plus 2 alpha beta minus 2 alpha beta. So basically, this is as good as the given term here. So whenever we have to find alpha square plus beta square, we can use this identity. Similarly, for alpha cube plus beta cube, we can use alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. So let's try to solve a question which involves the use of alpha square plus beta square calculation. For example, if a polynomial is given as 6x square plus x minus 2, and I need to find the value of alpha plus beta by alpha. So that means I have to find alpha square plus beta square by alpha beta. So my approach of the question should be to find alpha plus beta and alpha beta only, and then try and solving by using this method. So from this, I can say that alpha plus beta is minus b by a, so which is minus 1 by 6. Alpha beta is minus 2 by 6, which is minus 1 by 3. And then I have to just substitute in the values. Alpha plus beta is minus 1 by 6 square, minus 2 into alpha beta is minus 1 by 3, again divided by alpha beta, which is again minus 1 by 3. So this means I get 1 by 36 plus 2 by 3 by minus 1 by 3. And then this we can solve as, here it will be 1, here it will be 24. So you get it as 25 by 36 into 3 by 1 and a minus sign outside. So basically the value is minus 25 by 12. Also, next concept is, children, please remember, if anytime they ask you a question in which they have given that zeros are reciprocals of each other. Whenever reciprocal relationship of zeros is given, that means that we can say that alpha is basically equal to 1 by beta. Or we can say that alpha beta is equal to 1. So for a reciprocal relationship of zeros, always utilize that zeros alpha beta is equal to 1. For example, let's do a question based on this. If a polynomial is given as a square plus 9, x square plus 13x plus 6a, and then they say that one zero is reciprocal of the other. So what do we do in such case? We will take alpha into beta as 1. Or I can say that the product is 1. So that means from this polynomial, if I try to take out the product, which is c by a, will be given as 6a by a square plus 9, which is equal to 1 here because the zeros are reciprocal of each other. Then I go on solving this, and this will give me a square minus 6a plus 9 is equal to 0. And this is nothing but a minus 3 whole square is equal to 0. So that means I'm going to get the value of a as 3. So the question wanted to find the value of a if the zeros are reciprocal of each other. At the end, children, I have mentioned the top 4 questions. Please solve this, and if you have any doubts, please tell me in the comment section. Thank you so much.